Greetings to everyone. Today we will see about thermodynamics. Thermodynamics is nothing but the relationship between heat and energy, that is work done and energy and other processes. So in thermodynamics we will see about some basic concepts, literally some basic concepts. So you all know about well versed with the universe concepts and Big Bang theory and all. So coming to thermodynamics topics, so in thermodynamics we always speak about within system, that is system means a particular area or a particular system. Example, many types of systems are there. For example, isolated, closed and open systems are there. A system is nothing but a particular area in the universe, and the system is surrounded by an environment which is called the surroundings, and the boundary is nothing but the that is the boundaries in between the system and the surroundings, that is called the boundary. So the boundary protects it. A boundary may be adiabatic or diathermic. If adiabatic means there is no exchange of heat energy, in diathermic means there is an exchange of heat energy but there is no exchange of matter or any mass or molecules. Other systems are homogeneous system, heterogeneous system and macroscopic systems. So coming to isolated system. Isolated system means it is an insulated system where there is no transfer of heat and matter. There is no exchange of heat energy or say Q or any matter or mass. In closed system there is an exchange of heat energy but there is no exchange of matter or molecules. In open system there is both an exchange of heat energy and matter. So coming to homogeneous system made up of an homogeneity, that is uniformity throughout the system. There is always a single state, whereas there is in heterogeneous systems there are two phases or three phases maybe. There is no uniformity throughout the system. For example, in a system there is a solid and a gas, means it is a heterogeneous system. Coming to macroscopic system, we always deal with macroscopic systems in thermodynamics. Macroscopic systems deal with bulks of matter, that is properties of bulk matter and all. So coming to some basic concepts, the same basic concepts. Coming to macroscopic or thermodynamic properties. The macroscopic properties, that is thermodynamic properties, are two types: intensive and extensive. You all know about many questions that is intensive and extensive, about intensive and extensive. So intensive properties does not depend upon the mass, so it does not vary with the mass, whereas the extrinsic variables varies with the mass. If the mass varies, extrinsic variables varies. For example, let's take a bulk of matter like a block of mass. If we split into a two system, a block, if we consider a system to be a block of mass, if we cut the system or divide the system into two particles, the density always remains the same, that is the mass varies, so as the extensive variables, volume varies, number of moles varies and others also varies. Whereas the intensive properties such as density does not vary. The density remains in both parts as the same before, and pressure, temperature, boiling point, freezing point, viscosity, surface is also the same. So these are the intensive properties and these are the extensive properties. Then coming to thermodynamic variables. Thermodynamic variables, there are two types, that is state variables and path variables. State variables depends upon the state of the systems, initial state and final state, does not depend upon the path taken. That is whatever the path taken, it depends upon the state and state, that is initial and final state. For example, thermodynamic variables, example pressure, volume and temperature, and internal energy U and enthalpy H. Path variables depends upon the path taken. Example, heat and work done. They depend upon that which path they took to reach the final states. Example, heat Q and work done. And coming to thermodynamic equilibrium. Thermodynamic equilibrium in the sense the system is always in thermodynamic equilibrium with the surroundings. In which equilibrium? In all means of equilibrium. For example, chemical, mechanical and thermal. Chemical equilibrium means the composition of the system and surroundings remains the same. Mechanical equilibrium means there is no work done between the system and surroundings. Thermal equilibrium means there is no heat energy change or exchange of energy between the system and the surroundings. So if chemically, mechanical and thermally equilibrium with each other means system and surrounding, means it is in thermal equilibrium. We can say the system is in thermal equilibrium with the surroundings. So the heat is denoted by, heat exchange is denoted by Q. In thermodynamic variables, the heat exchange is denoted by Q, and in reactions, thermodynamic reactions, it is represented by H. Q is a path function, whereas the H is a state function. Then internal energy U is denoted by U, and the internal energy is nothing but the energy possessed by the matter. That is the energy of the matter means the energy possessed by the molecules. The molecule energy means vibrational energy, translation energy, there is motion in translation, vibrational, rotational energy, electronic energy, bonding energy, so many kind of energies. Then work done. Work done is all thermodynamic processes, there must be a work done. If a thermodynamic process to happen, there must be a work done. So work done may be mechanical work done or electrical work done or a gravitational work done. Mechanical work done is nothing but a common work done, that is work done equal to force into distance equal to P into V. If the volume varies, work done is equal to minus PV, minus P del V. Why there is a minus means the negative sign indicates that the pressure is inversely proportional to volume. If the pressure increases, volume decreases, and vice versa. Then coming to electrical work done is equal to potential into Q, that is charge, and gravitational work done is equal to mass into acceleration due to gravity into height. These are all the work done. Here you can note that Q, that is heat energy, and W are path functions, whereas internal energy is a state function. So for sign conventions, many students will confuse what is the sign convention between physics and chemistry. So in chemistry, the sign convention is heat absorbed by the system is Q is equal to positive, whereas the in heat evolved by the system Q is negative. It is the same as for a reaction. Del H is negative for an exothermic reaction, heat is evolved, and del H is positive for an endothermic reaction, heat is absorbed. Next, work done on the system is positive and work done by the system is negative. These signs are useful in solving problems. Next, coming to laws of thermodynamics. First is zeroth law of thermodynamics. Zeroth law of thermodynamics states that if two systems are in equilibrium with their third system separately, then the three systems are all in equilibrium with each other. So little bit confusing. Okay, let's see in diagrams. The left diagram shows the yellow line depicts, the yellow line denotes the diathermic wall. Diathermic wall in the sense it allows the exchange of heat energy, whereas the black line represents the adiabatic wall. Adiabatic wall means there is no exchange of heat energy. So for this system, you can say that temperature of A is equal to temperature of C, because the diathermic wall allows the heat energy to exchange. So it will be in thermal equilibrium after some time. So TA equal to TC, temperature of A equal to temperature of C. Here temperature of B equal to temperature of C. So at the same, we can also say and the temperature of A equal to temperature of B. By combining these two diagram concepts, we can say TA equal to TB equal to TC, because if temperature of A equal to temperature of C and temperature of B equal to temperature of C means it should be temperature of A equal to temperature of B. So this formula, the zeroth law, depicts that temperature, that is if two systems are in thermal equilibrium separately with a third system, then they are in equilibrium with each other, or all the systems are in equilibrium with each other. That's all. For first law of thermodynamics, coming to first law of thermodynamics, first law states that the common statement, energy can neither be created nor be destroyed. So first law states that if there is an increase in internal energy or any change in internal energy or any excess internal energy, del U means change in internal energy, that is final minus initial. So the change in internal energy will be contributed to heat exchange between the system and the surroundings and work done on the system or by the system. So heat energy is equal to work done plus heat energy. This is the first law statement. And in the enthalpy concept, del H equal to del U plus P del V. P del V is nothing but work done, which is equal to, we know that ideal gas equation, PV equal to nRT. So P del V equal to del Ng RT. Del V variable is equal to del Ng variable. Here you should note that del Ng means the del Ng depicts that number of it is the difference between number of gaseous products and gaseous reactants, not all solids and liquids. It is gaseous state. You should note this for solving problems. Many students mistook it and write it wrongly. Then coming to the most important topic, thermodynamic process. It is the main topic of this lesson. So thermodynamic process means there are a few thermodynamic processes. Let's say the main important thing is 4: isobaric, isothermic, isochoric, and diabetic process. So isothermic process means the temperature is constant throughout the process. So del T equal to 0. If the temperature is constant throughout the process means it is obviously the change in temperature is 0. So del T equal to 0. And del U equal to 0. That is the change in internal energy equal to 0, because there is no change in temperature. So it should be del U equal to 0. So we know that in first law of thermodynamics, U equal to Q plus W. If U equal to 0 means Q equal to minus W. So change in air exchange of heat energy is equal to minus of work done. So that's all. This is the main formula in isothermic reaction. So for isothermal reversible expansion, So we commonly talk about expansion and compression. So expansion in the sense the gas expands. Gas expansion means the volume increases, pressure decreases. So compression in the sense the gas compresses means the volume decreases whereas the pressure increases. So pressure is inversely proportional to volume. We already knew that. That's why W equal to minus P del V. In isothermal irreversible expansion, irreversible means the process cannot be reversed. In isothermal irreversible expansion, del Q equal to minus del W as we saw earlier. So del W equal to minus P del V. This is also we saw earlier. So del Q equal to minus del W. So del W equal to minus P del V. So minus into minus plus. Then Q equal to P del V. That's all. For isothermal irreversible expansion, the formula is del Q equal to P del V. For isothermal reversible expansion, the process can be reversed. There is no dissipation of heat or any kind of energy. So del Q equal to minus del W as we saw earlier, and del W equal to minus 2.303 nRT log Vf by Vi. This is a common formula in isothermic process. So you should learn del W equal to minus 2.303 nRT log Vf by Vi. Vf means volume, final volume, Vi means initial volume, R is universal gas constant, T is temperature in Kelvin, N is number of moles. So del Q equal to minus of minus into minus is plus. So 2.303 nRT log Vf by Vi. So then coming to adiabatic process. So adiabatic process means we saw earlier adiabatic valve does not allow exchange of heat energy. So as adiabatic process, there is no exchange of heat energy or there is no change in heat energy. Heat always remains constant throughout the process. So del Q equal to 0. So from first law of thermodynamics, we derive the formula del U equal to Q plus W. There, if del Q equal to 0 means del U equal to W adiabatic. So adiabatic represents the work done in adiabatic process. In isobaric process, the pressure remains constant throughout the process. So del P, change in pressure, is 0. In isochoric process, the volume remains constant throughout the process. So del V equal to 0 or W equal to 0. Why? Because W equal to P del V. So del V equal to 0, so W equal to 0. So there is no work done in isochoric process. In many years, in NEET exam, they will ask what is isochoric process or commonly what is the peculiar feature, del W equal to 0. For adiabatic process, del Q equal to 0. They commonly ask these questions. In del U equal to 0, they asked in many exams. So coming to cyclic process. Cyclic process nothing but the process, the process starts from an initial state, the process after over, the process coming to the same state. The initial and the final states are same. Simply say the initial and the final states of your process same. It is a cyclic process. So in cyclic process, all state functions are 0. State function means it depends upon the initial and the final states. It depends upon the state of the system and surroundings, not on the path traveled. So for a cyclic process, del U equal to 0 and del H equal to 0 because these are state functions. So initial and final states are the same. So del U, UF minus U initial, both are same means del U equal to 0. You have to note this in questions. They will ask questions like in the question in the initial itself they say it in a cyclic process. If you see in a cyclic process, then you can say del U equal to 0, del H equal to 0. For derivation, you can put all state functions equal to 0. Or you can, the answer will be also 0 if they ask the internal energy. What is the internal energy in a cyclic process? They will ask the graph and blah blah blah, the big question, but simple answer is del U equal to 0 in a cyclic process. Then reversible process, irreversible process, and the final one is quasi-static process. Reversible process means the state can be reversed to the initial state. The final state can be reversed to the initial state. The reaction can be brought back to the original position. Irreversible, the reaction cannot be brought back because in irreversible reaction there will be a loss of energy in friction and radiation, kind of other things, heat dissipation. What is quasi-static process? A question was asked in NEET something 2016 I think. And the quasi-static process means it is an infinitesimally slow process. That is, the system and surroundings is always in thermal equilibrium or in near equilibrium with each other. That means it is also a kind of reversible process. It is very slow process so that it maintains the equilibrium. The system and surroundings are always in near equilibrium relatively, let's say relatively. So it is kind of reversible process, or the main statement is infinitesimally slow process. You have to learn it. Then coming to PV diagram, the extensive PV diagram will be dealt in physics thermodynamics. So here we can say some overview. So there are two PV diagrams. The left one denotes expansion and the right one denotes compression. So compression of a gas. In expansion of gas, the volume increases whereas pressure decreases, and the x-axis denotes the volume and the y-axis denotes pressure. So see, there is 4 processes: isochoric, adiabatic, isothermic and isobaric. The difference between these two, the main difference is the relative difference of the curves, isothermic and adiabatic. Here the above and below, you should be very aware of that, because in exams they asked this curve and they put A, B, C, D and all, and they will ask what is A, B and C. You should first see what is this process, expansion or compression, then you have to answer. For expansion means, in expansion always the pressure and volume of isothermic process is more than or greater than the adiabatic process. If the pressure is constant or we attain a final pressure as same, the volume of initial isothermic will be greater than the adiabatic. So adiabatic volume and pressure is always less than the pressure and volume of isothermic in expansion, whereas in compression the pressure and volume of adiabatic is greater than the pressure and volume of isothermic. That's all. You have to very aware of this. You should learn the basic concepts. In expansion, pressure volume of isothermic is greater than adiabatic. In compression, pressure volume of adiabatic greater than isothermic. That's all. Are we clear? Then next is isochoric. Isochoric means the constant volume. So here is the constant volume. In compression, the pressure increases. That's why the curve is increasing this way. In expansion, the pressure decreases. That's why it decreases. Isochoric pressure, the constant volume. It is a vertical line in PV diagram. In horizontal line is isobaric, that is pressure constant. In pressure constant means isobaric, but volume changes. In expansion, volume increases at a constant pressure, so it increases. Whereas in compression, volume decreases. That's why volume decreases in isobaric process, whereas the pressure is constant. That's all. Are we clear? So we'll go to next. This is the main basic things of PV diagram. You can solve whatever you want. But in physics, then thermal properties of matter and all, you have to learn about the PV diagram, or let's say in states of matter in chemistry, the 11th first volume, you have to learn about Boyle's law, Charles' law, to define what is the main PV diagram difference, the inversely proportional, directly proportional and all. So this is the common thing. I think you understood very well. Then coming to heat capacity. Heat capacity is nothing but the heat capacity or the energy are required to raise the temperature of a substance to 1 degree. That is for water it is 14.5 to 15.5 degrees Celsius. Heat capacity is a common word, that is Q by del T. Specific heat capacity is a specific word, that means the temperature required to rise 1 gram or particular mass 1 gram to 1 degree Celsius. That is specific capacity, Q by M into del T. Whereas the molar specific capacity is 1 mole. So C denotes the molar specific capacity is equal to Q by mu del T. Mu denotes the number of moles. So molar specific capacity, for definition we say the temperature required to energy required to raise 1 mole of substance to 1 degree Celsius. That's all. Then the relation between Cp and Cv. Cp is nothing but molar specific capacity at a constant pressure, and Cv is nothing but molar specific capacity at a constant volume. We derive from the first law of thermodynamics, that is H equal to U plus del Ng RT or P del V. Cp minus Cv equal to R, we derived. And gamma, that is the ratio of specific molar specific capacity, is equal to Cp by Cv. It is a constant for monoatomic, diatomic and triatomic polymetric, and it depends upon the degree of freedom. So coming to Hess's law of constant heat summation, some questions may ask, some examiners may ask from this also. It is nothing but the total enthalpy of a reaction is the sum of the individual enthalpies of a reaction. Simply we can say, or we can say if a this is an initial reactant and this is a final product. A to B is a one reaction, B to C and C to D. B and C are intermediates. If A to B, the enthalpy involved is del H1, and from B to C the enthalpy involved is del H2. C to D the enthalpy involved is del H3. For total reaction, the enthalpy involved is del H. These are total enthalpy of a reaction. So total enthalpy of a reaction is equal to del H1 plus del H2 plus del H3. That's all. This is the basic thing. If any problem asked means it is easy to solve. Next, enthalpy and bond energy. This is the most important topic for solving problems. Many problems or maximum number of problems will be asked in this question. If you know this topic very well, then you can solve any problems. So this is the main thing where most of the students get confused and got wrong. So enthalpy means enthalpy of reactions. Reactions means there are many reactions: formation, combustion, combination, decomposition, discretion, hydration, whatever, many reactions are there. You have to differentiate enthalpy and bond energy. There is in bond dissociation also there is an enthalpy. Enthalpy is nothing but change in energy state. That's all. So for formation, the formation enthalpies are there. Formation reaction, the enthalpy is formation enthalpy of formation. Combustion reaction, atomization, vaporization, solution, dilution, fusion, sublimation, hydration, tension, many reactions, all reactions except bond energy, bond dissociation enthalpy, except bond dissociation enthalpy, bond energy, for all reactions enthalpy total enthalpy or enthalpy of a reaction is equal to enthalpy of product minus enthalpy of reactant. You should very clear about this. Enthalpy of reaction equal to product minus reactant for all reactions except bond enthalpy. Bond enthalpy is equal to del H, total reaction enthalpy is equal to reactant minus products. For bond dissociation, it is reactant minus products. Bond enthalpy or bond dissociation energy or bond energy, whatever you can say, if there is a bond, James bond, it should be reactant minus product. So del H equal to total reaction enthalpy equal to del H equal to reactant minus products. That's all. This is the main thing many people will ask in the questions. That's all. So next another one important is lattice enthalpy or Born-Haber cycle. Simply say it is an enthalpy diagram. So lattice enthalpy is nothing but it is related to ionic compounds, solid ionic compounds. If a solid ionic compounds dissociate into gaseous state into its ions in gaseous state, if NaCl in solid state dissociates into its ions, constituent ions, Na plus gaseous state, Cl minus gaseous state, then the enthalpy involved is lattice enthalpy. So lattice enthalpy defines that an ionic compound dissociated into its constituent ions in gaseous state. That's all. So that total enthalpy is lattice enthalpy. For constituent enthalpies, we have to equal lattice enthalpy equal to sum of constituent enthalpies. So from the bottom we start, that is NaCl at solid state. NaCl solid state dissociates into Na solid state plus half Cl2 gaseous state. The enthalpy involved is dissociation enthalpy of NaCl. If it reverses, that is Na plus Cl2 gives NaCl, means it is formation enthalpy. That is the sign also reverses. So dissociation enthalpy equal to negative of formation enthalpy. Dissociation enthalpy of NaCl is equal to Na plus C plus half Cl2. If the solid state becomes gaseous state, Na solid state becomes gaseous state, the enthalpy involved is sublimation. You know that solid state into vapor means it is sublimation. You learnt in the pre-KG class even, that is liquid or solid converts into, example camphor converts into gas, it means sublimation. So the enthalpy involved in here is sublimation enthalpy, solid to gaseous state. Others are same, Cl2 half Cl2 gases are the same. Next, ionization enthalpy means Na gaseous state to Na positive ion gaseous state. Here there is a loss of electron. Ionization means loss of electron, that is removal of electron. So ionization enthalpy involved here. So Na gaseous state to Na positive ion gaseous state means the involved enthalpy is ionization enthalpy. And chlorine is same as before. Then coming to Na plus gaseous state and half Cl2 to this half Cl2 changes to Cl, that is Cl bond is broken. The enthalpy involved is bond dissociation enthalpy. So this reaction, the enthalpy involved is bond dissociation enthalpy of Cl2 to Cl. All are gaseous state, here also all are gaseous state. Then if the chlorine acquires an electron, the enthalpy involved is electron gain enthalpy. Here you can see Na plus gaseous state the same as Na plus gaseous state, whereas the chlorine gaseous state becomes chlorine negative gaseous state. So enthalpy involved is electron gain enthalpy. Then Na plus gas state and Cl minus gas state gives NaCl as solid state, the enthalpy involved is lattice enthalpy, or vice versa also it is lattice enthalpy. NaCl dissociates into its ions and gas state also lattice enthalpy. So we can say lattice enthalpy involves the combination of all the things. So are we clear? So Born-Haber cycle is simple as this. If you have any doubt, there is a link in the description, you can post it. You can fill the form and send it to me, or just submit, it will automatically received in my email. I will post again this video if you have any doubts. If you have any doubts regarding solving problems also, you can post. So coming to entropy. Entropy is nothing but disorderness or randomness of an equation. It is a wrongdoing thing, okay. For all spontaneous process, entropy increases because in all spontaneous process there is always a loss of energy. Maybe friction, whatever, loss of dissipation, thing. So all spontaneous processes are irreversible processes because of the loss of energy. So entropy increases in all spontaneous process. So entropy is noted by S. So change in entropy is equal to Q by T. For reaction we say del H by T. And there are many reactions: fusion, evaporation, sublimation. They are all spontaneous reactions. So for fusion, the enthalpy is enthalpy of formation. Evaporation, enthalpy is enthalpy of evaporation. For sublimation, the enthalpy is enthalpy of sublimation. Then coming to Gibbs free energy. Gibbs free energy is nothing but the energy, that is the maximum energy available to a system to convert it into a useful work. That is, the system possesses a maximal energy, that is Gibbs free energy, simply we can say. So Gibbs free energy is the maximum energy, that is maximum work done, we can say. Next, the relation between Gibbs free energy and del G equal to del H minus T del S. T is temperature, del S is entropy, del H enthalpy, del G is Gibbs free energy. We know that the W equal to minus 2.303 nRT log K. K is equilibrium constant, T temperature in Kelvin, R universal gas constant, N number of moles. If we eliminate this 2.30 means it would be ln, natural logarithm, that's all. So del G naught means standard Gibbs free energy. Standard in the sense it happens in standard temperature, that is 298 Kelvin, and standard pressure 1 atm, atmospheric pressure. Then in cell reactions, del G equal to minus NFE. F is Faraday, N is number of electrons involved in the cell reaction, E is EMF of the cell. Whereas the naught symbol represents del G naught is standard Gibbs free energy, minus negative sign, and N is number of electrons involved, F is Faraday, E naught is channel EMF of the cell. The negative sign denotes the opposite variation of del G naught and del G naught. That's all. Coming to the last topic, spontaneity of a reaction. The spontaneity means this the relation between enthalpy, entropy, and del G, or that is reactions Gibbs free energy relations with the spontaneity of a reaction. For a spontaneous reaction to happen at all temperature, we already saw del S is positive, entropy is positive for the reaction. So del S is positive for all spontaneous reactions at all temperatures. Remaining are negative, del G is negative and del H is negative. Coming to non-spontaneous reactions. So in non-spontaneous reactions at all temperatures, irrespective of the temperature, del S is negative and the remaining are positive. Del G positive, del H positive. So this is easy to remember. For spontaneous, del S is positive, remaining negative. For non-spontaneous, del S is negative, remaining are positive. So another how to, if the temperature varies, the signs also vary. How to remember easily means, for spontaneous reaction at high temperature, let's say for spontaneous reaction at high temperature, del RG, reactions Gibbs free energy is negative and the remaining are positive. The same concept. For non-spontaneous reaction at high temperature, del G is positive and the remaining are negative. That's all. We knew for spontaneous at all temperature, del S is positive. Spontaneous at all temperature, non-spontaneous at all temperature, del S is negative. Here, spontaneous at higher temperature, non-spontaneous at higher temperature, del G varies positive, negative, remaining are opposite effect same. For non-spontaneous reaction at a low temperature, all are negative. For spontaneous reaction at a low temperature, all are negative. For non-spontaneous at low temperature, all are positive. Sorry, that's it's an easy way to remember. The basis is spontaneity related to entropy, positive and negative. That's all. So apart from the first and zeroth law, there is a second law of thermodynamics. So it is many statements are there in second law. The main concept given in the NCERT and the many curriculum is Kelvin-Planck statement and Clausius statement. Kelvin-Planck statement provides a statement that it is impossible to convert heat completely into work. That is, the efficiency can never be 100%. It is impossible to convert the petrol's heat energy completely into work. There is always a pollution, there is always heat energy dissipated to the surroundings, there is always heat energy in our buds. There are lots and lots of there. Next, Clausius statement. Clausius statement provides the statement that it states that the Clausius statement is nothing but it is impossible to transfer Clausius statement states that it is impossible to transfer heat from the colder object to hot object. You cannot transfer heat from an ice to a hot bath. Is it possible? No. So that the Clausius statement, it's impossible to transfer heat from a colder object to a hot object. It is obviously, they said in the previous times, so it is a law. Their name is here. In the future, our name will be there if we saw something. If we say something. So come to third law of thermodynamics. Thermodynamics, it is the statement that entropy of all perfectly crystalline solids approach 0 at absolute 0 Kelvin. So absolute 0 is nothing but 0 Kelvin. So what it is means, the entropy is 0. Where it is 0? If there is no disorderness, if the crystalline solids are perfectly in ordered positions, if the constituents of crystalline solids are in perfect order, it will be the entropy is 0. Where it will be imperfect, order the absolute zero condition, that is in 0 Kelvin the entropy, the perfectly crystalline solids are and its constituents are in perfect order, so entropy is 0. That's all. Simply say at 0 crystalline solids and are perfect, so entropy is 0. That's all for today. The physics chapters and the many sums and the sums will be taken in another video, another class, and the physics thermodynamics will be dealt in another class also. That's all. If you have any doubts and feedback, you can submit in the form. There is a link in the description.